is Nadhirah Binti Muhammad Amin, and this is our team members: Nurul Farhana Binti Omar, Nasriyah Binti Abdul Jalal, and Sharifah Nabila Binti Syed Razman. First and foremost, we would like to thank to Madam NAZIHAH Binti ISMAIL, our lecturer, who was a continuous source of inspiration. She encouraged us to think imaginatively and motivated us to do this assignment. She expressed her full support and provided us with the many teaching tools needed to finish this project. We are also grateful to each and every member of this group. This assignment would not have been a success without the contribution of each and every participant. We are also grateful to our parents for always believe in us and encourage us to believe in our skill and capabilities and to never give up until we reach our goals. We are grateful to all our friends who offer a moral support. But most of all, we are grateful to God for being with us and provide us with the knowledge and capacity to complete this mission.
What is the differentiation? Differentiation is a method of finding the derivative of a function. Also, can be defined as a derivative of a function will be applied to measure the function with respect to an independent variable. Differentiation is a process in math where we find the instantaneous rate of change in a function based on one of its variables. The most common example is the rate of change of displacement with respect to time called velocity. Lastly, to differentiate a function, one uses differentiation rule and techniques such as the power rule. This rule enables one to calculate the derivative of a variety of functions.
When do we apply differentiation? First is analysis of function 1, which increasing and decreasing functions and concavity. Second is related rates. Third is maximum and minimum problems. Next, Rolle's theorem and mean value theorem. And last but not least, we have analysis of function 2, which is relative extrema for first and second derivative.
What is rational function? A rational function is a function that is the ratio of a polynomial. Any function of one variable x is called a rational function. It can be represented as fx equal to px over qx, where px and qx are polynomials such as qx not equal to 0. We know that every constant is a polynomial and hence the numerators of a rational function can be constant. So here we show you the simple example of rational function.
How to identify the rational function? By the definition of the rational function from the previous section, if either the numerator or denominator is not a polynomial, then the fraction form does not represent a rational function.
What is application of rational function in our daily life? There are three applications of rational function in our daily life. First, speed and time. Using single, independent variable and equation, you can solve the value of several different functions. You also can determine how long it takes for both of those functions to be complete. Second, photography. The method is highly suited to frame cameras and non-linear effects caused by lens distortion, film distortion, and atmospheric effects. Third, medicine. Doctors use the rationale to predict how patients will metabolize medication over time. We will move to the example question and let us show you how to solve the problem so you will more understand about it. Let's go, guys.
So here we have an example question about graph of rational function, and this is past year question on March 2017. So please pay attention to this video. The question is given the function fx equal 5 minus 2x over x plus 3. A. Find the x-intercept and y-intercept. B. Find the vertical asymptote and horizontal asymptote. C. Find the intervals where fx is increasing or decreasing. D.
find the intervals where fx is concave up or concave down. And last E, sketch the graph of fx using the above information. Okay, now to solve the previous equation, we need to find the x-intercept and y-intercept. Okay, to find the x-intercept, we need to assume that y is equal to 0. Then solve the equation as usual to find the value of x. And as the result, we got that x is 5/2 and the coordinate is 5/2, 0. But to find the y-intercept, we need to assume that x is equal to 0. And next, you need to change the value of x to 0. Then solve the equation as usual to find the y value. And as the result, we got that y is equal to 5/3 and the coordinate is 0, 5/3.
Next, how to find vertical asymptote and horizontal asymptote. To find vertical asymptote by setting the denominator x plus 3 equal to 0 and the solution we got as equal to -3. To find horizontal asymptote, we need to apply the limit. First, apply limit x approaches to positive infinity 5 minus 2x over x plus 3. Second, we need to divide the polynomial with the highest power. Then divide the equation with x because x is the highest power in this equation. And we got 5 over x minus 2x over x divided by x over x plus 3 over x. Then we got 5 over x minus 2 divided by 1 plus 3 over x. Evaluate the limit and the answer we got 0 minus 2 over 1 plus 0. And the answer we got y equal to -2.
Next, this is the answer for question number 3. The question asks us to find the intervals where fx is increasing or decreasing. So, to solve this question, we must make our 5 minus 2x as our u and x plus 3 as our v. And then we use question rule to differentiate the equation. And then we substitute the value into the question rule. After we differentiate, we must let the fx as 0 to determine it is the answer has solution or not. And then we make the table to determine the either increasing or decreasing. For fx prime, you can choose any value more smaller than -3 and the opposite for the next column. Oh, we only have 2 columns of the table. First, smaller than -3 and second, more than -3. And for the slope, we got increasing for both of it.
So now we will find the interval as where f8 is concave up or down. As we know that f prime is equal to -11 over x plus 3 the power of 2. Then we will get f double prime is equal to 22 over x plus 3 the power of 3. We need to let f double prime is equal to 0, so the answer is 22 equal to 0. There's no solution, so this is how to know whether the graph is concave up or down. First, by use the equation f double prime is equal to 22 over x plus 3 the power of 3. So the result is we got x equal to -4 is concave down and x equal to -2 is concave up.
Here the summary we got of the answer or the equation. First, we got x-intercept which is coordinate 5/2, 0. Next, y-intercept we got a coordinate 0, 5/3. Then for vertical asymptote, x equal to -3 and horizontal asymptote y equal to -2. By all the information we got, we can use to sketch the graph So please stay tuned on this video because we will teach you how to sketch the graph easily.
To sketch the graph, first thing first, you need to plot the vertical asymptote and horizontal asymptote to know which quadrant the graph is. Then, by using the information of x and y intercept, you will got the first graph. Second graph will be opposite to the first graph. As the result, the graph is located in quadrant 1 and quadrant 3. At the end of the video, what we can conclude is we understand how to solve the question about graph of rational function. We also have covered how to find x and y intercept, the vertical and horizontal asymptote, and more. Other than that, we have learned something new, which is we knew what is the uses of the rational function in our daily life. Lastly, we can sketch the graph correctly based on the information that we got.
Here are some references we use. Thank you for watching our video. If you have any question, just let us know.